good afternoon, students. I'm Nick Rizzita. I'm the computer science supervisor for Loudoun County Public Schools. It is a pleasure to have you out here for the Elevate Loudoun Internship Fair. This is the last internship fair for the school year, but not the last internship fair that we are going to have moving forward. So don't be concerned. Even though Mrs. Lee talked about this being the last one this year, we are going to continue to have internship fairs moving forward. Real quick, I'm going to introduce our guest in just a moment, who's going to discuss quantum computing, which is really fascinating to me. What we're going to do is once Dr. Rosenberg goes through her presentation, we're going to open it up to questions. I'll just ask you all to raise your hands here inside the Google Meet, and then I will call on you and you can unmute your mic and ask your question directly to Dr. Rosenberg. So without further ado, I'm in just a second, I'm going to turn it over to Dr. Jessica Rosenberg, who is a professor at George Mason University. And we met a couple months ago because we are working to expand quantum computing here in Loudoun County Public Schools. And I'm thoroughly excited by this project because I think it's great that we teach computer science in Loudoun County, but I think it's fantastic to keep up with the technology that's actually taking place in the workforce and in the global community. And that's what Dr. Rosenberg is working to help us do here in Loudoun County. So it is my absolute pleasure to introduce my friend and colleague, Dr. Jessica Rosenberg. Dr. Rosenberg, take it over.
Great, thank you. Thanks for the introduction, and I will apologize for the echoiness of my background. As I was saying earlier, I am in a space where they're doing a blimp robotics competition. So it's a little loud and echoey, and my apologies for that. But I'm going to talk a little bit about, as it says, jobs at the quantum limit. And it's quantum computing, but it's actually a lot more than that. And I'm going to start with a little bit of an introduction to quantum itself and what it is and why we think that this is actually a field that's going to expand tremendously in terms of industry, and why students like yourselves should be learning something about this as you prepare for the workforce in the future. So quantum is how things act and behave at the very, very small scale. And so, for example, scales of electrons, where a tip of a needle can hold billions of those electrons. And so part of the thing about quantum is that things behave what seems to be weirdly based on our normal experience of big things. And this is actually a wonderful YouTube video, if you ever get a chance to look at it, the Dr. Quantum double slit experiment. And I think in our normal world, you sort of know that if you shoot BBs at a slit, you get a pattern, the pattern you should say pattern, not pattern, that you would expect on the other side, right? A row of points where those BBs have hit and come through the slit. Similarly, if there are two slits, you get two lines. What happens when you shoot electrons or light or another quantum particle through those slits is very different. In fact, the pattern that you get is much more similar to what you would get if what was traveling through those slits was a wave instead of a particle. So more like water than a BB, where if there's one slit, you get most of what you see in the center, right? And it tailing off to the edge, this bright green spot in the middle, right? Fainter on the sides. And with two, these distinct lines as you go out, where those waves come together and either add together or cancel each other out as they run into each other at the screen. And so one of these pieces of weirdness, or what we often refer to as superposition, which is the idea that actually those electrons, one way to view it, and there are different ways to try to understand it, most of which involve the mathematical representation of it. But the idea is that at somewhat level, the electrons are actually going through both slits at the same time. They're going through neither slit, and they're going through one slit or the other. And they're actually doing all three of those things at the same time. They're in a superposition of those three states. And it's the only way for us really to explain the behavior that we see for these objects. So again, if we observe the electrons as they pass, they make the BB pattern instead of the wave pattern. But it's once you do this double part that you get two. The other way in which quantum is weird is this thing that we call entanglement. This idea that you can create particles that have to have opposite properties no matter how far apart they are. So that no matter how far apart they are, if you measure the property of one, you know the property of the other because you've created them together to be opposites. And this is actually the property of quantum particles and quantum behavior that Einstein referred to as spooky action at a distance. That you could know the properties of something very far away based on this. And it's actually based on these properties that people are starting to build the first quantum computers. They're using it to understand quantum sensing, how you observe things using quantum behaviors, and also communications and cryptography, how we send messages and receive them across distances, right? If you think about the entanglement piece, to know what your key is, right? To know what the behavior of something is at a distance. And again, so why is this important as we think about jobs and development of workforce and ultimately internships? And the idea is that it's really changing the world that we live in. Our first computer revolution was based also on quantum mechanics, really, and our ability to use some quantum properties for our benefit. But this new quantum revolution is really about manipulating those properties in a way that we haven't been able to before to generate entanglement and superposition and use it for computing in particular, but also in other areas of sensing, how to build very complex sensors. We're using that understanding in biology. We're actually better understanding how biology uses they're like birds and their compasses, that magnetic compasses is actually a quantum phenomenon. So we're starting to understand more of those things as well. So our view in terms of who should learn about quantum is everybody should know something about this. It's going to be part of your world as you go out into it. And so these jobs that are going to exist and are already starting to exist make use of quantum both in science, as I said, in sensing, computing, cryptography. But in addition, business people for the businesses that are created around these technologies are going to need to understand and know how to use this. Communications, advertising, and marketing, right? So it's going to be fairly pervasive across society, and having some understanding, and obviously the levels of understanding will vary depending on the job type, but it's going to be broadly important, or we think it is. So we've been working on developing a lot of pieces for this, and I'm not going to go in too much detail about sort of these experiences. I will note that beyond high school, we're starting to put things in place at Mason so that there will be opportunities. Right now, we have some of the initial courses in this area. We're hoping to start developing a minor in quantum for students across the disciplines so that you could add a few courses to what you're studying to understand more about it. We've developed a master's program as well and are looking to expand on that. So there's lots of things available as you hopefully get interested and excited about this area and what it can do, and paths that you can take moving forward. So I wanted to put this up and hopefully these will be available so you'll be able to also grab at it. But these are some of the programs that exist. Some I know better than others. But I also wanted to put what we're doing for this summer. And as I was starting to say earlier, we're in the process of figuring out whether these will be funded opportunities, but we will have opportunities regardless. We're hoping that they will actually be paid opportunities within this. And some, they're still being finalized. So not all of these are final. So I can't guarantee each of the experiences will look at like the ones listed here and on the next page, but there'll be similar things. Certainly, I will be looking for people to work with us as we're trying to work with teachers and students to develop curricula. How do we actually get this stuff taught in the schools? And so students with an interest both in learning about quantum, but also possibly teaching and communications, we'd love to find to work on this. Hopefully this assessing the quantum market will become available. This is one of the industry partners that we're working with who is hoping to do that. But at Mason, there's a combination of both lab and sort of computational experiences, right? This quantum sensing with graphene. So this is actually physical sensors and building these sensors based on their quantum properties. So one of the key qualifications there is, skillful hands, because they're actually creating these devices and building these devices. Synthesis and characterization of topological materials. These are some of the materials used in this. So it's more of a lab-based opportunity. But then there are several that are more computer-based. UAV trajectory optimization, right? How you actually get unmanned autonomous vehicles trajectories optimized. It's really a math problem at some level, but it's a computational one that quantum computers should be really good for. And I will not tell you the details of the quantum coherence witness. It's also a programming problem, and we'll get more details on some of these as we go. But I will stop there. I want to put this up. We have posted the link for applications. We will be asking for teacher recommendations as well. And so this is going to be the place to go, but I will stop there and look for questions. I'm also going to close this so I can see what's going on, since I can't see. Oh, shoot, it does. How do I stop share? Stop presenting. There we go. Because otherwise you get the infinite tunnel problem.
Yeah. Dr. Rosenberg, I wonder if you could share.
I will share the slides with you so that you can share them. Yes, I was hoping there'd be some way to do that. So let me.
Okay. And students, I will work with Mrs. Lee so that she shares that out with you all via email, so you have all that stuff. All right, students, like I said before, so Arjun, I saw that you just asked a question. Do you want to, I see that you said, are there any required prerequisites for this internship? Dr. Rosenberg, do you want to?
Yeah, so let me say that the answer is no, right? What I was trying to show with those lists, especially at the end, right, is we think there's going to be a wide range of things, and different backgrounds and skills are going to be appropriate for different ones, right? There are a few of them that I know probably will require some prior, programming experience, but there are plenty of others for which it's not, right? Willingness to get in the lab and learn stuff is part of it. So it's a pretty wide range, which is why I say that if this sounds exciting and like something that you want to work on, then go ahead and apply. We're working on a deadline because, as I said, this is a little bit fluid right now. It's probably in the next couple of weeks, and I will try to get that information passed along when we have finalized the deadline. For now, I'd say if you're interested, start thinking about applying, come take a look at it, and we will get that final date out to you. It's been a little bit of a fluid situation for a variety of reasons. So.
Yeah, so Rishi, just to echo what Dr. Rosenberg said, the application is forthcoming, and we'll give you the due dates for sure once those occur. And Mrs. Lee and I and Dr. Rosenberg will work with you all on that.
Yeah.
Kartika, thank you so much for raising your hand. Go ahead and unmute your mic and ask your question.
Hello, I was just curious, like, who exactly do interns work with? Is it like college students since it's associated with George Mason, or like also professors or like other companies?
That's a really good question. And I will say, so most of these that I listed are at Mason, as you point out. There are a few we're hoping to add that are within industry. So those would be people working in industry. At Mason, it will vary a little bit by which project it is, right? So the ones that are, the education one will be with me and my group. So I think most of them, the faculty member will be involved, but some of the labs in particular, you'll probably have more interaction with graduate students and postdocs who are running, often do a lot of the running of the lab. I think all of these faculty are in the lab a decent amount of the time, but not always. It'll be more of a mix there. So it's it's a fairly broad range. It's hard to give you one answer, but it's an excellent question because it does vary depending on which opportunity it is.
Great question. Students, anyone else with a question?
Also, is this just a summer internship or like into next school year too?
For now, it's the summer. We are going to look into what we can do during the school year, but yeah, we hope to expand it to have other opportunities as well.
Thank you.
Yes, absolutely. Mrs. Lee will share the application forms with you all for these internships. She's working with Dr. Rosenberg and myself on, what this is going to look like. So great question. All right. If there aren't any other questions, Dr. Rosenberg will stay on the. There are a few other questions coming through the chat.
Here we go. Will we be able to explore areas other than the ones we applied to, or do we stick with just right now? I think the way that we're planning to work it is you apply generally to the program, and you'll rank sort of the kind of opportunity you're interested in, and we'll match you at some level with the various ones. At which point there'll probably be a further interview type discussion and make sure it's a good fit for both. So it will be more sort of, do you want to be in the lab? Do you want to be doing more programming? Do you want to do more of the education type opportunities? But as Nick says, the details will be forthcoming. That's the hope, that it will be a paid internship for the summer. That's one of the main things we're in the process of trying to put into place. Sort of mostly a question of timing as to when we can get our funding. We know we have it. We just don't know how soon we can get it.
Andrew, we're going to make sure that we email everybody who attended today's internship fair with the updates that Dr. Rosenberg and Mrs. Lee can provide us. So we'll make sure that we send an email out to you and everyone who attends. So I assure you, when those application forms come out, we will email, and we'll also share with your teachers as well, because this is something that is a priority for Dr. Rosenberg, Mrs. Lee, and myself. So we assure you, we'll communicate them out.
Hoping to do this very soon. It's a little late, I know, for you all planning your summers, but we're getting there.
Dr. Rosenberg has been extremely patient, that's for sure. She has. Good question.
Good question. So my guess is this will be a mix, right? There are certainly at least a couple of these that are online or hybrid, but most of them will be in person. Certainly all the lab type internships will be in person. And some of the others probably will be as well. Because you can't build quantum sensors at home. You'll have to actually be in the lab for those. But at least one of the industry ones that we're hoping to line up is people all over the country. So that one's definitely online. So it's a mix.
All right, I'm failing with my wait time, but all right. Well, at this point, we will stay on the line until you all leave this room. Thank you so much for coming out and listening to Dr. Rosenberg. I think that she's providing us with some phenomenal opportunities. So we really look forward to sending out those applications to you. And like I said, Mrs. Lee will get that out to you as soon as we get some more information. So thank you for coming out.